there, AP Environmental, and welcome to Ecosystems Ecology. In this video lesson of the living world in ecosystems ecology, you're going to learn about the movement of energy. Like some people in some countries, some ecosystems are more productive than others. The term gross indicates the total amount of energy captured by the producers. So the gross primary productivity is the total amount of solar energy that the producers in any ecosystem capture via photosynthesis over whatever given amount of time it is we're talking about here. Net primary productivity is the energy captured by producers in an ecosystem minus the energy producers respire. So it's their net. So the net primary productivity is equal to gross primary productivity minus the respiration by producers. You can think of GPP and NPP in terms of like a paycheck. GPP is the total amount your employer pays you, while NPP is the actual amount of money that you take home once taxes are deducted. So GPP is essentially a measure of how much photosynthesis is occurring within that system. When solar energy strikes the Earth, about 99% of it passes through our system or passes through reflectively, I don't know if that's a real word or not, outside. And producers typically only capture about 1% of the available solar energy that they convert with photosynthesis. This 1% capture is what we are calling GPP, the gross primary productivity. About 60% of the gross primary productivity is typically used for respiration. So the remaining 40% of GPP is used for growth and reproduction of the actual plant itself. So this is known as net primary or net primary productivity. 60% of the gross primary productivity is lost through a process called respiration. So I know that can be a mouthful and a little confusing. So NPP, net primary productivity, is equal to gross primary productivity minus respiration. So why is this energy transfer, this energy capture so non-efficient? Why only capture a small percentage of it? Biomass is the total amount of mass of all living matter in a specific area. When we talk about a standing crop, that's the amount of biomass or living matter that's present in an ecosystem at any particular time. And we can actually look this up. There are numbers and people whose job it is in order to come up with these charts and figure out the biomass of certain ecosystems. Ecological efficiency is the portion of consumed energy that can be passed from one trophic level to another. So most organisms can transfer somewhere between 2 and 40% energy. And the 60% of energy that they have lost is usually lost as heat. Producers contain more of the original energy, so the best example I have of ecological efficiency would be if you were eating meat, like you ate turkey or chicken for every single meal, you're putting a higher demand on the environment because the tertiary and secondary consumers don't have as much energy that's contained within them as the actual plant material. So a trophic pyramid is a representation of this distribution of energy. And we distribute it a couple of different ways, like by the biomass, by sheer number of individuals, or energy. And most of the time I've seen it as energy distribution. So here we have a trophic pyramid of the Serengeti ecosystem. And this represents the amount of energy that's present at each level. We measure energy in joules, While this pyramid assumes that 10% of energy is the true number, that's your ecological efficiency. Actually, the system ranges somewhere between 5 to 20% across different systems. So this is the diagram that we taught you in, ninth grade biology, perhaps. Maybe if you've taken AP biology, you've seen this exact same diagram. The truth is that we've tested this on multiple times, and there is a true diagram and true representation of energy as it's passed through the systems. It's not a clear-cut 10%, but each level does range somewhere between 5 and 20%. When we look at NPP and ecosystem and trophic diagrams, we can now compare the energy that is trapped within a system amongst different systems and basically determine, who's the most productive. As you can see from this diagram, the energy in the productivity is in grams per centimeters cubed each year. And so with that measurement, you can look at the different ecosystems, either terrestrial or aquatic, and determine who has the most productivity. When you're looking at this diagram, I hope you can see that our wetlands, swamps, and marshes are highly productive areas, more productive than a tropical rainforest, which is just this rich and wonderful environment for you to learn environmental science in.